Welcome, everyone. We have pivoted these online sessions to what we're now calling the discussion series. We're very excited to have you here. My name is Alex Riepsam. I am the head of research expertise and knowledge at Singularity. I am also the facilitator of our open enrollment programming that we do. And I'm joined today by speaker today, Robert Suarez. I'm also joined by Cody Hansen, who is not just a colleague in our small but mighty Singularity team, but also very much the online host for the upcoming Biotech program. I will be the in-person facilitator and Cody will be the online facilitator. So this is a great time for me to stop talking. I will let Cody and Robert have a conversation about everything to do with bio-informed innovation.
Thank you, Alex. And thanks for being here, Robert. We have a lot of really good interest in this topic. I'm personally interested in this topic. I think it's really cool. So I want to start with like kind of just give us a quick, a little bit of your background. What makes you qualified to kind of be a pioneer of this space?
Sounds good. Thanks, everyone. Thanks for your time. As context, I started, I was traditionally a designer by trade, right? I learned how to sketch things, 3D objects, and um, 3D models. And then I ended up as a toy designer. That was my first job out of school. So it was great. I would sit there and just sketch ideas all day, like 40 sketches a day. One of those ideas might make it to the next phase. And eventually, I fax drawings to China and they make a model and send it over and eventually a product. And if it didn't fall off the ship on the way, it would end up on Target's store shelf. Um, and then eventually into the wasteland. So I knew I had to go somewhere a little further upscale or upstream in the innovation process, and I landed at IDEO, as a researcher. So it became more important to me to understand what we should design versus not just what it looks like, right? Because I was trained in here's what it looks like, but what is it that's most important, most valuable to people, and then eventually plan it. So nearly 9 years I survived at IDEO. It was an amazing place as a director, but this was 2012. Yeah, 2012, San Francisco. Startups were coming up around me, right? They were just like challenging the existing models of large corporations with a 12-person team. Like Pinterest was like, oh, we'll just do this faster and better than everyone else. And I think certainly this crowd of experts in the understanding disruptive technology, right? I was living in it and I was seeing it go by, and I couldn't get my clients to market as fast as these startups. So I left to join a fintech. We're Kleiner Perkins back, so we were able to get to scale and plateau, and eventually was sold to Capital One. That gave me a chance to kind of step back, and I'd spent, at this point, that was my half of my career. I'd spent it all in human-centered design. Like, what is the need of that person I'm observing, or the people, or the surgical suite, or this manufacturing line? How can we use design to improve that, design and innovation? But it was missing the systemic view, right? What does the ecosystem need? So really, I went and got my master's in biomimicry and took that, people and planet. And the fact that we are nature, we are biology. So kind of taking a different view outside of just human centered into maybe a system centered approach. And that really drove me down this path of people and planet. Um, that's where I ended up at Singularity. And we were running SU Labs out of NASA Research Park. We had startups, corporates, nonprofits coming in, leveraging, what our whole ecosystem of experts and faculty could share. How can you leverage these emerging technologies and point them in the right direction, right, for your community or for the planet? So, years of that, and then since then, been doing startups and projects in this space.
Yeah, yeah. So bioinformed innovation, which you just alluded to, is something you kind of observed through some of your companies and just some of your work. Can you explain like what that is and also why it matters to someone who maybe isn't even thinking about biotech in terms of their industry, like isn't in healthcare, isn't in sustainability or any of that kind of stuff. Like, why does what is bioinformed innovation and why does it matter?
Well, for me, I guess it started with the idea that biotech. Um, for me, it was a different framing. It's not a vertical, right? And I just realized we always use biotech as a vertical, and we say, all right, and so 99.9% of the funding and support is in human health. If you see it as an enabling technology, which it really is, biology, biotech is just an enabler, then it changes from an industry vertical with those limits um, to eventually a mindset and certainly a reframing of how I approach these things. So for many, it's a practice, it's a passion area, it's a study. You go to these universities and people have been curious about biology, and now the tools are enabling them to apply that in new ways, right?
Yeah, right. Which I think speaks to how we think about everything at Singularity and also how the biotech program is being designed, which is, yeah, you'll learn about like what's the innovations that are happening in biotech, but just as or more important is how these are impacting application areas, vertical agnostic, right? Across verticals. And so that's we've kind of planted a flag in the ground saying, the biotech will be as disruptive and impactful to business and society as AI is being currently. Um, I want to get your thoughts on that, and then also, what are some examples for folks of industry breakthroughs that have happened, outside of healthcare, outside of biotech, that have come from this type of thinking that you kind of off the top of your head.
Right. That's a great question. I think for me, just to build on that, right? We're talking about innovation that's designed from, with, or leveraging biology and biological processes. Generally, and what we'll talk about is how we can do that to evolve the way we bring products, services, new models into existence. So, really, thinking about it as the processes or leveraging biology. Um, Areas that are most interesting are new materials and new capabilities, right? And these are things that map back to the industrial revolution, right? We figured out new ways to use new materials to do things, right? I don't, you can look at metals and any kind of materials that were involved in that space, and I think you have to take that same mindset here. What are the new materials and what can they do better? Whether it be fire resistance or thermal regulation, right? How are they made and how can they scale? Right. So we'll talk about the scale because there's a lot of stuff going on in labs right now, but there's that big jump from just being in a lab to making it boundary level, as we say. There's certainly a new process for making things and also replacing existing with better alternatives. And I'll put better in quotes because it could be better on a number of different criteria.
Yeah, and I'll kind of put you on the spot. Like, do you have some actual like companies or products that you're seeing right now that are exciting in this space?
Yeah, I think if I go down the list, let's start with materials and manufacturing. I think look at textiles. I review a number of companies in textiles as an example, right? Because all the clothing, and we've probably all seen the images of where our fast fashion has led, us on the planet. Um, Bloom out of New York, really just taking. So one of my theses for at least investing and working is waste to value. So that's a framing. Um, they're taking, things that old corn husks and things like that. Or, what is this that we're currently using it? It looks like waste from our agricultural processes. What can I turn that into? And that's like the underlying question a lot of companies I meet. And they've realized, oh, I can, this if I do this right, I can turn it into textile and create t-shirts in a new way, right? And this guy had come from a textile company, so he knew the end goal was to put it into our existing manufacturing processes. So it's really kind of simple. You take the capabilities of what we consider waste, and you use biological processes to turn that into something that we're familiar with, right? And the shirts
Mhm.
feel soft, and they so there's that. Cosmetics is close to that. Hard goods. The company that I'm really close to is called Marvel Labs. And Jake, the founder, was curious. He was working, I think he was like at a coffee shop, and he's like, "What? Look at all these coffee grounds they're used, and we're going through these insane amount every day. What can I do with this?" So he went on the pursuit of re-engineering 3D printing to use coffee grounds or other things that we can powderize with an all natural binder to create hard goods, right? Toilets, sinks, and like really dense and useful objects. Um, so we invested in them and
Nice.
working with them to kind of get to that what we're calling 4D tech. There's ways to kind of isolate uh, objects in space, and then with this all natural adhesive, kind of freeze them in space. So I think we've talked about additive manufacturing for the last 30 years. I know
Right.
we're still waiting, but I'm glad to see people pursuing and working with people who pursue this additive manufacturing because it allows to localize this idea of onshoring that is even uh, more vivid now with this new administration, right? Reshoring or onshoring manufacturing is probably one of the biggest arguments for this bioinformed innovation.
Yeah, that's a great segue. I want to talk about that because you talk about kind of a shift from global to more local manufacturing, more resilient manufacturing, lower waste. Um, can you speak to that? Like what I guess give people kind of a 101 of what that is, like what local responsive manufacturing is in your eyes, how that relates to biotech, like how biotech maybe fuels that. And then, we can talk about how it might impact global supply chains down the line, 5, 10 years down the line. But like, what
Right.
is local manufacturing?
Well, for me, it's the idea that it's a principle of being locally tuned and responsive. And this is one of our principles of biomimicry, right? So understanding what is local to you and responding to things in the environment, things in the processes, things in the community, policies, all these things around it. Our current manufacturing processes, right? Things are sent overseas and then come back in a different way. Um, that's not locally attuned and responsive. It doesn't know where it's going to end up in the end, and really the inputs and outputs, right? So I'll take Jake and Marvel Labs, but if there's something that is considered a waste, it could be grass clippings, right? You powderize those, that's the local waste product that we can turn into something else. Now, what can we turn it into? Right. And that's responsive to the needs of that community or that business or that market. So both the input and output can be localized. And obviously that can happen in a small community, in a small area. And that's not really true in most processes right now
Right.
because we're doing things that heat, beat, and treat, is what we say. So you need these big machines, these big foundries to create the same thing over time. I think bioinformed innovation can be more adaptive for sure.
Do you see this being, I mean, this sounds idyllic, right? Like ideally every small community across the world like creates a large majority of their own goods and reduces waste. It seems like kind of a utopia type of vision. But it sounds like you're kind of saying that we're headed that way, or that will be the more economic viable way to do things. Is that an accurate statement, or would you push back on that? Is there like work to be done to get to that point, or does it just make business sense to go that route anyway?
I think it makes just common sense to get back to that because
Hmm.
it's not that that never existed. I think other organisms, other species do it, right? And they've been doing it
Right.
for 4.8 billion years in some cases. Um, we just have to retune to be able to do that. And it takes a lot, right? So I said, certain species or anything, look out your window wherever you are in the world. I know people from all over the world, but look out and there are species there that are doing this locally attuned and responsive approach to design. Like what are the inputs I have right now and what can how can I leverage this moisture? How can I leverage this soil? Whatever it is. Um, we just need to catch up to that because those species have been doing this for a billion years and we're a very young species. So we have to kind of figure out, iterate our way into it. So it's not easy given where we are, but I don't it will be more beneficial and people will understand that this is why didn't we do this before?
Right. Right. Something that's really interesting to me personally that you've talked about in the past is bio-based mining. Can you go into what that is? I had never heard about it before. I heard you talk about it. It's just a very curious aspect of this world.
Yeah, it's one of the areas that I'm areas of focus for me right now.
Okay.
Again, with this waste of value or the idea of, as I guess everyone knows, there's, rare earth elements is what I'll say. Like there's certain elements and critical minerals that that are required to electrify everything in the future for us at this moment. There's new ways to develop batteries that are being worked on, but currently we need critical minerals to do this, and so we're mining these, and you can walk across the states and see these large mines, but there's new ways to harness those critical minerals that we need. Two that I'm most interested in are phytomining and biomining, right? Um, and I'll talk about phytomining because it was a shock to me. I met this person. I was studying her work at the Salk Institute in San Diego, just a plant expert. And there are certain plants that are hyperaccumulators. They have the capacity to accumulate metals out of the ground. Like they just do this naturally, right? So she was studying these and she's figuring out ways to supercharge that acceleration. So you see where this is headed, right? If we get these super plants, hyperaccumulators in old mine sites where there's plenty of minerals and metals in the ground, you can start to extract those through this biological process and pull those for high value. They're high value minerals, right? At the same time, you're bioremediating the land. So to me,
Hmm.
it's the most elegant visualization, execution of this waste of value thesis.
Right.
So phytomining is incredible. It's really tough to find people doing it, but when you do, I kind of latch on. And we'll be meeting her in San Diego.
Amazing.
Yeah.
Awesome.
But the
Um,
biomining side is really just, I think a lot of them are taking the tailings, the waste that happens in mines, and using biology to further extract the minerals from that space.
okay. And so that's like like what, a bacteria or something, or how does
Right.
that
Yeah. There's a number of things you can do that kind of identify those minerals and start to, it's just, for me, what my learning was is there's a lot of it is just separation,
okay.
right? So and you don't have to use biology necessarily, but it just accelerates it, makes it easier, faster, cheaper to do it. Sometimes there's some of these materials just float differently, right?
Hmm.
Than others. So you can use all these different techniques to separate minerals to pull out the stuff you want and leave the stuff you don't. And that's really where there's a number of different biomining companies who are doing, taking different takes on this.
So zooming out a little bit, that's super interesting. And the thing that's popping into my head is like how you find this kind of stuff. And I assume, I mean, that it's kind of, it's your job, right? Is you're an investor in the space, and I think that's really cool. You kind of just get to be a nerd about this stuff and go hunt this stuff down. But like, what does that look like for anyone who might also be interested in investing, whether it's through their company or through themselves, either for a particular use case, developing a new product, or to be an investor across the space? What does that kind of what does that process look like? Are you just like researching every day and trying to make connections and uncovering these hidden gems, or is there like a systematized kind of way of going about figuring out what's going on in the biotech space?
It's a learning curve, and I'm still learning and iterating through it. But I think if you're interested in the space, however you want to fund, support, uh, get a job doing it, right? I think the process is the same in some ways. I started with just I have a practice of just funnel. Like I have to look at everywhere I can. But we're necessarily early stage, and some of this work is being done in labs. So
Hmm.
I realized that, and I started to find like things like the Salk Institute or Scripps Institute. These things are in San Diego. They're all over these universities. I spent time at some of the UC systems, the California schools, um, and start digging around and asking questions. I think what I've realized, different from my background in tech and design and products, um, scientists are very open to collaboration. I think that's another pillar of this bioinformed innovation that I found different, right? Scientists a lot of times have just come in, they're in labs working together, learning, sharing learnings and building on each other. I think we saw this in the digital world in the past, like people code together.
Hmm.
But it was refreshing to see this in the space of biology in the labs. Now, the trick, so you get collaboration. A lot of times, at least the way I'm looking at it, is for net benefit of people and planet. So again, you get this shared mission. So
Right.
all of a sudden, people being more collaborative and sharing tools and sharing methodologies. There's companies that are even sharing like fermentation, right? So they're like,
Wow.
"Oh, I have the vats that you need. Why don't you come over here and do your work in my lab?" Which is great, right? So that all lays a foundation. The trick was to find folks who are for us is who are investable, who want to actually be and can be entrepreneurs. Um,
Right. There's
it's
a gap between a good scientist and a good entrepreneur, and some cover that gap and some maybe don't. I hope you're enjoying this conversation as much as I am. We'll hear more from Robert right after these quick messages.
What if 5 days could transform the way you think about the future of your business, your community, and yourself? Welcome to the Singularity Executive Program. Join a curated group of 100 senior executives from around the world in Silicon Valley, guided by 20 world-class experts exploring breakthrough technologies and exponential innovation. From AI to renewable energy, from biotech to space exploration, reshape your understanding of what's possible. Transform your mindset, disrupt your industry, and build our future. Applications are now open for 2025. Visit su.org/EP.
While everyone's talking about AI, there's another accelerating revolution that will transform every industry: biotechnology. This May, in San Diego, California, join world-class experts and visionary leaders to explore how biotech will reshape manufacturing, finance, energy, the future of work, and beyond. From biomanufacturing to digital biology, bioinformed innovation to neuroscience, discover how this technology space will disrupt markets and define the next decade of business. The future of biotech. Space is limited. Reserve your seat now at su.org/biotech.
I think the best are the ones like people, we're doing some battery tech, and they're like, I want to stay tenured university. I don't I'll take my equity. You guys will go find a real CEO because it's not
Right.
me, right? And I love that when you've
Yeah.
so,
Self-aware. Yeah. I've done some work in the grant funding space in the past, and there is a ton of opportunity in like the tech transfer, like going to universities and finding innovations and technologies and products, and then helping them commercialize those. Because to your point, a lot of researchers want to do the research, and they would love to see that research propagated out into the world, but don't know how or want to go into the business side. And so there's a natural fit there. I think for startups and investors, but probably also I would guess for corporates who are looking at new products or new disruptive innovation for their organization. It's actually something I hadn't thought about before you brought that up, but like using the university system wherever you are in the world as a fuel for innovation, I think is a really important thing to bring up as a good partnership that both sides win. Um, on zooming out again on folks that maybe aren't developing new products, right? We've talked a lot about product innovation and how you come up with these new things, but maybe someone is just trying to figure out how to make their organization work better. Thinking about bioinformed innovation from that perspective, do you have any thoughts or guidance on someone who's just trying to kind of figure out how to use nature or biology as an inspiration for better business operations, better communication, better leadership, that kind of stuff?
there's a whole practice in organizational design, and I think that's a great place to apply biomimicry, and a lot of people are doing that. Um, how do species coordinate and sometimes and often compete, right? And how and what can we learn? Now, there's always a asterisk where just because it happens with other species doesn't mean it's most appropriate um, for humans in the
Hmm.
work. But
Right.
you again, we just talked about this collaborative nature of scientists as well as climate tech, right? So that's a learning here. I think adapting to changing conditions. You can look at all the principles in nature that have allowed whatever. Look out your window. That tree has been around for a long time because it had to adapt to the changing conditions, the changing weather, humidity, whatever it is. You know, and then you translate those principles to yourself, your organization, your community, or whatever you're designing for. Um, in San Diego, we're going to go through a workshop where people can apply, nature's principles to
Hmm.
their family, themselves, their workplace, their large companies, right? So that's the workshop that we'll be running, and I think we can dig deep because um again, to that local attune, everyone's going to come with a different locale that they're designing for. So we've set up the workshop to do that. But it's a lot of how you take a principle that's successful in nature, abstract it, and then apply it to your needs.
Build a framework out of it.
Yeah.
Right. Amazing. Okay, let's take a little bit of a left turn here and cover technologies broadly. We've been focused on biotech, bioinformed innovation, but as the fellow for innovation at Singularity at large, um, what are some converging technologies that you're expecting to be relevant in 2025, maybe including biotech as part of that?
Well, there is a convergence in again this digitization. We've learned to digitize relatively recently. We've learned to digitize biology, right? So, for me, there's ideas of like I'm really focused on Earth-friendly computation as a general space, as one example where we've digitized biology. We can, manipulate DNA, um, and then we can do data analytics on top of that. So for me, it opens up a whole new world of a couple things, and we're seeing that we're reading that every day. All of us are reading the news about data servers, AI, and the need for speed and energy. I think one big space is thermal regulation and energy for data centers and computation.
Mm,
And then that kind of modularity and the edge data centers is something that I'm very fascinated with, right? Everyone's kind of using large language models right now, but most people don't need those, right? Certainly the big companies and people doing heavy computation do, but hospitals, schools, like these places need future computation capability, but they don't need these large language models. So for me, there's a huge space there. And then the regulation and the thermal regulation, because we're doing it inefficiently, right? Computation right now is not efficient. No one cares, but eventually we will. Um,
right.
yeah. The
Yeah.
last part of this, like the big one that I'm hunting is DNA data. So the
Okay. In
ability to
what way?
store information in DNA is fascinating, right? Right. I don't know. I still have like a hard drive somewhere. There's one in my computer.
So are you saying that like instead of a hard drive, we could use DNA as data storage?
Absolutely. All right. So if you take this
Really
trend
interesting.
of digitization, right? Take an email, the simplest email. And so
Mhm.
people are doing this, are working on this. You take that email or that message, a note to your friend. You translate that to ones and zeros. You translate those to ACTG. And then you create DNA that is coded with that email, and we're done. Stage one. The tough part is actually getting it back. But it's
Right. And
possible you can do that. It's just not as efficient yet.
so like you could like use your house plant instead of an external hard drive one day to store your emails.
Or a piece of fruit could store your entire life.
That's full
From
sci-fi, but I
every
love
photo that you've ever taken in your life, you can just put it in orange or papaya. We have a project internally that we call papaya, and it's focusing on this space.
That's wild. That almost even it's funny. I mean, working at Singularity, I get exposed to a lot of wild things, but that's like that one maybe takes the cake. That's pretty cool.
It is.
And it ties
I
in.
just not pitching for the biotech, but we're gonna. My friend that I'm working on with this, I think he'll be joining us too, so we can kind of dig deep in real life on some of the madness that is
Yeah.
DNA. It's really cool.
Yeah, I mean, that's kind of what we do at the program, right? Is like go deep into the madness of it and like see what really is on the edge of what's going on so you can kind of map back to what to do, now, this week, this year, planning ahead toward that. And I know that we'll have Tiffany Vora with a whole kind of segment or block during that program on synthetic biology, which I think ties nicely into that work, which is basically the science of turning DNA into code or manipulating it like it were code. And so it's interesting because you think about gene editing and CRISPR and those things as everyone talks about it as a healthcare application, but you're basically taking it back the other direction and looking at it as a computational solution, which is super interesting. If you had to give just like an elevator pitch for bioinformed innovation and biotech in general, just a couple of sentences on why understanding these areas and what's happening in them is essential to future success, no matter what kind of business or government or part of society you're in. What would that pitch be? Like why people should care about this?
Well, I guess that would be my elevator pitch is like no one's questioning the application of biotechnology for human health, right? That
Mhm.
means some are, but really like, oh, good, that'll help cure cancer. That will help me live longer, right? Um, if you look at it a little differently and we apply it again, then 99.9% is being used for human health support. If we apply it to planetary health, we are part of that. It is related to our actual selfish health
Right.
needs. So it's just a little bit of a different look on how we can help ourselves, I guess. Let's take AI and these emerging technologies because we're all living in it now, or quantum because that's coming soon. Um, as we know, at Singularity, you have to look at other enabling technologies and then the convergence of those. They're not going to not overlap and touch each other, right? So I think the biology, right, in computation, we've seen everything that AI can do, but that it's fairly limited compared to biology. Biology, you can transform manufacturing, supply chains. We talked about human health, material science, all these things are within arm's reach of biology. AI and quantum computing they need something to be able to affect that, right? They can't just do it on themselves. So I think biology opens that door of hardware physicality that we haven't quite seen yet. And then look at any of the big headlines right now. And, I live in California and we just had these terrible fires. I live in fire country, so I think about this a lot. The way Alex she asked me about this a while ago. If I could change one thing, it would be the built environment. So there's areas where we need to be applying this now as an experimental as an R&D to see how we can make homes more resilient. And that changes insurance, that changes finance. Like it really scales out as we've
Right.
seen in LA. If we could make our homes, not even livelihoods and families, right? We can affect all those outer circles all the way up into insurance if we build differently. We just haven't questioned our home designs, our home building, our home materials, right?
Yeah, I mean that's something that at the very beginning is cool to see with companies like Icon where they're 3D printing, buildings. I mean they're using fairly standard kind of concrete based materials. So there's a lot of materials design and engineering that can be done still. But the construction industry in general um has a lot of room for innovation, and I like that this connection between biology and the physical world, like the built environments, the real space, because you think a lot of people think a lot of times about innovation as tech. And there is so much application area in or sorry, but not tech, but digital, right? And there's so much application of technology and innovation and new thinking in the physical world that I think has I think everyone can probably agree is for the most part lagged behind the digital space. And so getting back to that to actually improve our quality of lives, our economies, our communities, all the things that we really care about, right? Because we care about being good at business, but in most cases, being good at businesses or our jobs is the end result goal is that we improve our families, our lives, our communities. So being able to tackle that at the ground level is I think a really exciting thing and a big piece of where this type of thinking can come into play. I love that. All right, awesome. But let's jump into the questions, Alex. What do we
Yes.
got?
So one of the questions was about, well, how is bioinformed innovation intersecting with 3D printing or advances in 3D printing? Then about well, what about the AI and quantum energy needs? So, that those are two sort of like different directionally, but sort of like we see these interplays of different technologies. Um, could you speak a bit more to some of the sort of like maybe most explicit interactions that you see coming out of this space with the other technologies that we study at Singularity?
Okay, so the intersection with 3D printing, additive manufacturing in general, like Cody touched on 3D printing homes, and there's companies that are doing that well. But if you think about things, it helps me to think about biomineralization, right? It's a natural process where organisms look out your window or look in the ocean. They're especially good at it. Um, Produce minerals to form structures, right? So shells, we're all familiar with bones in ourselves, right? Teeth, all these things are biomineralization processes, which would be really interesting if we could harness that capability for sustainable manufacturing of things Cody was mentioned concrete, right? The homes that survive were concrete. Concrete's one of the biggest. It's the most one of the most used materials for us. One of the biggest emitters. So why don't we rethink that? And companies are using biomineralization as a process to create concrete or a version of that. There's also potentially self healing. So it's not like, oh, let's replace it with something that worse. No, let's build on top of existing concrete, make it in a better way, make it with, cheaper and less energy, but also self-healing. So like if it's damaged, it can self-heal because of biomineralization. The current concrete that we walk on in the cities is not able to do that. So if you think about, for me, that is one of these great processes that we need to mimic and harness, um, and really kind of bio-utilize, which is a weird word for biomimics, but we could just steal that technology of biomineralization and apply it to rebuilding homes in LA.
And then to the energy question of like the needs that some of our other technologies are giving us in terms of what they need in energy to
Yeah,
function or to
absolutely.
improve.
Again, this is like when I think about that, it's energy required as well as efficiencies and back to thermal. So thermal regulation, right? That is energy. And what are we doing? We're not capturing it well. Big companies are exploring, if we put this underwater, then we can use water to cool and mitigate that energy release. But um biology does this well as well. Look outside, and that tree somehow is able to be in 0 degrees and then 100 degrees, and it, thermal regulation happens all over the place. We haven't applied that to these new emerging technologies because they're so new, right? We're just getting our heads around these processing, and the Nvidias of the world are certainly looking into this, but I think it's a huge opportunity space. Anyone in the audience who wants to build another startup, it's a good place to play because there's going to be a need there. Whoever asked the question probably knows more intimately, but the energy requirements of these computational models it's not going down, right? As more people get their hands on AI, it's just going to keep going.
And it almost seems like there's kind of blinders in the tech world on bio inspiration. I mean, I'm sure some people are thinking about it, but it seems like there's not a focus on. It's more just brute force, put all the metal and machines together, and then use air conditioning unit. That kind of thing. Yeah.
You're right. I think they don't call it that, but neural networks, these things were inspired by biology, whether we call it bioinformed or not. It's like how the brain works. Oh, we should mimic that with computational models. Um, but I generally you're right. I think it's just we're running fast with this,
Mhm.
trying to produce them very quickly, which leaves room for disruption. All right, all the entrepreneurs in the audience is like there's a lot of space there to play.
I have two more sets of grouped questions. Okay, so what are some of the what areas of ethics within biotech are already better established, and what are some of the ones that might still need to be figured out? And similarly, so if you have like re-engineering waste to a t-shirt, like what are the metrics that are used in order to ensure that that's happening sustainably, right? We know that with a lot of, for example, the vegan leather space, the materials that are being used are actually much more detrimental, and the material is much less sustainable. So it's like this, what kind of metrics or standardizations are in place and to ensure that that actually does what it needs to do in terms of improving processes, kind of in that same space as like thinking about the ethical implications of um, some of these technologies. What do you see happening in the industry?
Well, I think it's the right question because we always have to ask this, and I'll go back to what we always said at Singularity when this always comes up, regardless of technology, biotech or AI. It's we have to fundamentally trust that humans are good. And if you ask me on any given day, it might be 51% to 49 leaning like I think we're gonna be okay. Because you put these tools in people's hands and we've seen what happens, right? Or some days I go the other way. And you can see this with, I don't care, take social media, take whatever. Like we know that there are implications. We know that humans are making decisions to use these tools. So as it relates to biotech, it's it's the same answer. It's like the people that we trust to do this work. We hope that they do it in the best way possible. Now, what's really concerning here is like certain things that we're talking about, if you let that out of the box, you can't just pull it back. You can't just course correct a line of code as we're all used to now, right? You put something out like, oh, that chatbot was not very nice. Why don't we fix that? If you do that with some of the stuff we're talking about, in biotech, then you can't just go grab it and fix it. And that's something certainly worth tracking.
That are you referring? I recently lost my mind diving into this. Here's how you can imagine that it turned into a book. Diving into the mirror life um, bacteria. There's like mirror microbes, and there's been this whole like industry wide, just like some of the AI researchers did. All of these synthetic biology researchers who said like mirror life, mirror microbes. Let's all just not do that because we have no idea what the repercussions of that are. Are the hosts worried that the Trump administration will shut down funding to expand this new thinking? I think beyond the sort of like specificness of that question, I would love to also hear you speak about, or what are some of the incentivizations that are actually making sort of like they are going into this space? Is there independent funding, government funding, and that goes similarly into sort of like the breeding ground that we see in education for people interested in this space? What are some of the external factors that you're seeing either drive um, interest or waning interest into the opportunities here?
Well, let me track back. I think what's very exciting for me is that a lot of people are just curious about biology. Like they grow up, they're like, "Well, how does that grass grow?" Right? As a little kid, whatever it is, and then they go on to school and they study biology. And until recently, it hasn't been really an outlet for that to bridge into startups because I didn't everyone's like, oh, I should take computer science, but I don't like that. I'd rather study biology. And now there's a potential. This is what we're talking about, is that overlap where the door is open now for you to be a great biologist but also be an entrepreneur or work at a materials company. And so I do like that. I get the STEM, but I think that biology has been a natural curiosity which should feed the funnel of people. To Cody's point before, certain people don't want to be entrepreneurs. They want to go work like I think there's a lot of opportunity there. So I'm not necessarily worried about that because the human curiosity in ourselves, our biology, the world around us should feed this funnel of thinking in this space. Um, Back to I don't know. No one else does where policy and funding and support is coming from. I think the ARPA-E system is still amazing and there's a lot of work there. And again, the way I frame it internally for us investing wise is like this reshoring, onshoring, and managing for our country to manage our own supply chain. All the things we talked about, everything we talked about for the last hour feeds that purpose. So those things are very well aligned, right? Locally, attuned and responsive, new materials that we can develop here. So that is my argument thesis and how it relates to this incoming administration.
Thanks, Alex. Thank you everyone for being here. Thank you, Robert, for your time. And really looking forward to diving in deeper on just the crazy stuff that's happening in this space at the Future of Biotech program. Um, again, join us if you are able. You can join us in person in San Diego. I think this is an important field. I hope that you all feel that as well. I think that you do because you're here. And I think there's a big aspect of us building a world that we want to live in that is not just ruled by tech and by neural networks and AI, but is feeding back and forth between the biology that we are obviously very much a part of. So thanks for your interest. Thanks, Robert. Thanks, Alex.
Thanks, everyone.